Okay, so today we are going to start the Carnot cycle. Carnot cycle. Carnot cycle is the one of the very important cycle, and you can say it is an ideal cycle for all the heat engines. So ideal cycle means what? The cycle which does not exist actually, but theoretically, or this cycle, taken as a standard cycle for every actual cycle means all the actual cycles want to become the Carnot cycle. So certain special feature with this Carnot cycle. That's why we are saying it is the ideal cycle. So how we can study the Carnot cycle? So we study the Carnot cycle with the help of PV and TS diagram. PV and TS diagram. So P is the pressure, V is the volume, T is the temperature, S is the entropy. Now PV diagram means pressure is taken along the y-axis and volume is taken along the x-axis. In TS diagram, temperature is taken along the y-axis and entropy is taken along the x-axis. Now guys, this Carnot cycle consists of 4 different processes. So since Carnot cycle is a reversible cycle, it means all the process which are under the Carnot cycle will be reversible process. So since this process consists of this cycle consists of 4 processes, so this is the process 1, this is the process 2, this is the process 3, and this is the process 4. Now I am naming it process 1, this is point 2, this is point 3, this is point 4. Process 1 to 2, process 2 to 3, process 3 to 4, process 4 to 1. Now 1 to 2, this is represented by P12. It is a isothermal heat addition process. Process 2 to 3, that is named as P2 to 3. This is isentropic expansion process. So isentropic expansion process. Now 3 to 4, named as P34, is the isothermal heat rejection process. Now process 4 to 1, named as 4-1, is known as isentropic compression process. So here guys, since it is isothermal process, so temperature remains constant. Since process 2 to 3 is the isentropic process, change in entropy remains constant. And process 3 to 4 again is the heat rejection process. So again this is the isothermal process, and here entropy remains constant. So all these processes can be represented on TS diagram. Now see how we can represent on TS diagram. So see, process 1 to 2 is isothermal process, means temperature remains constant. So point 1 is I am taking point 1 over here. Then since it is constant temperature line, so this is the temperature axis, so line will go straight, vertical, horizontal. Now this is point 2. Now 2 to 3 isentropic expansion means entropy remains constant. So entropy represented along the x-axis. So this line goes again straight vertical. Now this is point 3. Then 3 to 4 is the isothermal heat rejection. So again temperature remains constant. So this 3 goes towards horizontal line, and this is point 4. Now 4 to 1 is the isentropic compression where entropy remains constant. So this 4 will be joined by 1 with the help of straight vertical line. Now 1 to 2 represented by this arrow, 2 to 3 this arrow, 3 to 4 this arrow, 4 to 1 this arrow. Along 1 to 2 what happened? We are adding heat Q1 to this Carnot cycle. 2 to 3 entropy remains constant. Then 3 to 4 heat rejection takes place. Q2 goes out from the engine. Then 4 to 1 again compression along the isentropic process. So this is what the TS representation of PV diagram. Now Carnot cycle, again I am repeating all these diagrams. Carnot cycle consists of 4 different processes. Process 1 to 2 isothermal heat addition, that is represented by process 1 to 2 in PV diagram and 1 to 2 in TS diagram. Process 2 to 3, it is isentropic expansion process. So in isentropic expansion process, entropy remains constant, that is represented by 2 to 3 in TS and 2 to 3 in PV also. Then 3 to 4, it is a isothermal heat rejection process. So 3 to 4 is represented in PV diagram, and in TS diagram also heat got rejected. Now 4 to 1 is the isentropic compression process which goes along the constant entropy. So 4 to 1 is represented on TS as well as PV diagram. So here 4 different processes makes a Carnot cycle, which is a theoretical cycle, and it is completely a hypothetical cycle. That means it does not exist actually, but all the engines want to become the Carnot cycle, reason being it has 100% efficiency. Okay, thank you.